Hi, in this question, the focus of a parabola is 1, 2, the focus of a parabola is given, and the directrix is the line y equals -4. So they gave us the focus and the directrix. We have to find the vertex of the parabola and the we have to find the vertex of the parabola and the equation of the parabola. So the first part to find the vertex is really easy. Let's try to do that. But this is one of those questions where you have to apply a lot of skills together in one question. It all comes together in one question. So if you don't remember a couple of topics, you won't be able to do this question well. So before we talk about the vertex and the equation, let's understand what the focus and the directrix are. So the definition of a parabola says that a parabola is the set of all points at an equal distance from a point called focus and a line called directrix. That means no matter what point I pick on this parabola over here, for example, if I'm trying to pick the vertex which is on the parabola, if I count the distance towards the focus, I have to go 3 boxes up. That'll be 3, the distance is 3. What about the distance from the vertex to the line called directrix? When I count down also, I get the same distance, 3. Now this is true for any point on this parabola. I'm not saying that every point on the parabola is 3 blocks away from the point focus and the line directrix. That's not what I'm saying. For example, if I'm picking another point xy over here, this point xy over here where I have the check at, okay? This xy will be the same distance away from focus and the same distance away from directrix. That could be, let's say it's the number 4.5. So if this distance d2 is 4.5, d1 has to be 4.5, otherwise it's not a parabola. So every parabola will satisfy this equation. So d1, the distance d1 will be equal to d2 for every single parabola. No matter where I have x and y, the distance from that point to the focus and that point to the directrix will be the same. Now this here, when you look at the graph, d1 does not look like d2, or it doesn't look like they're the same length, because it's a rough graph. I've not drawn a perfect graph over here, that's why. So having said that, let's go back to our first part of the question where we have to find the vertex. Let's plot the focus first. The focus of this parabola is given to be 1, 2. That's my x-axis and that's my y-axis. So 1, 2 will be right here. This is where my focus is at. Focus is 1, 2. And the directrix is the line y equals -4. So that's my -1, -2, -3, -4 is right there, my last line over here. That is my line y equals -4. So I know that the vertex must be right in the middle. The distance from the vertex to focus is the same as the distance from vertex to directrix. So when I count here, I have a total of 1, 2, 3, 4, 5, 6 units between them. So obviously 3 is the center, so right there. So this distance from the vertex up to the focus is 3, and from the vertex down to the directrix is also 3. It's 3 boxes down, 3 units up, and 3 units down. So my vertex right in the middle, which makes the coordinates of my vertex as 1, they share, focus and the vertex share the same h coordinate, 1, and my y is -1 here. So those are the coordinates of my vertex. Now what we need to find is the equation of the parabola. Now to find the equation of this parabola, what we have to do is we're going to pick a random point xy, and by the definition of a parabola, we know that the distance from that point xy to the line directrix, let's call that distance d1, and the distance from that point xy to the focus, let's call that distance d2, we know that by the definition they're both going to be equal. So we're going to find both these distances and we're going to equate them, and we're going to derive an equation of a parabola from there. Okay. So in order to do this, we have to know d1 and d2. So let's talk about that first. The distance d1 is the distance between a point and a line. I want you to look at this example here, this graph here. Here, let's say this is a point xy and this is a line y equals -4. This is a line y equals -4. How do you find the distance between here and here anyways? From this point and this line anyways. So we know that this is 1 on the y-axis and this number here is -4. So 1 minus of -4, we know the total distance is supposed to be 5. Or we can just count the boxes, 1, 2, 3, 4, 5. That's how we get the 5. Okay. In other words, to find the distance between a point and a line, we just have to subtract the y coordinates. So if I don't know the point, it's just an x and y. I'm just taking the y coordinate of this point is y minus of -4, which can be written as y plus 4. Okay, so that's how we find the distance d1. Now we have to find the distance d2, which is the distance between the focus and the point. This is d2. Okay, to find d2, what we have to do is we have to first realize that d2 is a distance between 2 points. The first is a point called the focus and the second one is a random point xy on the parabola. How can you find the distance between 2 points? So the next screen explaining that distance between 2 points, we want to call that distance as d2. In this case, is found by the distance formula. So if you have two random points x1, y1, x2, y2, the distance between them is given by square root of y2 minus y1 the whole square plus x2 minus x1 the whole square. Or in other words, difference in y coordinate square plus difference in x coordinate square. Now, so this is the point d2. So to find d2 in this case, what we have to do is we find the difference between the y coordinates. So y, I'm going to write the distance here, d2. The distance that we want to call d2 is given by y minus 2 the whole square. That's the difference in the y coordinate plus x minus the x coordinate here is 1. So x minus 1 the whole square. So that is our distance d2 in this case. So back to our question. We already found the vertex of this parabola. Now we have to find the equation of the parabola. Now we are going to find the equation of a parabola by equating two distances, right? The first distance is the distance. I'm going to pick a random point xy here, as I showed you in the other examples before. And I'm going to call this distance as d2, the d2. And I'm going to call the distance between the point and the directrix as d1. So equating d1 to d2 will give me the equation of this parabola. Let me show you how it's done. Now d1, if you look at the distance d1, it's the distance between the point xy and the line y equals -4. Okay, so when I showed you an example, when you have a point xy and a line y equals -4, we found out the distance to be y plus 4. So this is our d1. Alright, so I'm going to go back to my first screen and I'm going to call d1 as y plus 4. Now d2, if you look at d2, d2 is the distance between a point called focus and a random point which is xy. Let's go to the screen where we discussed d2. It's right here. It's the distance between 2 points. One is focus 1, 2, another is the point xy, which we already did it. We found that distance to be square root of y minus 2 square plus x minus 1 square. So instead of, back to our first screen, instead of d2, I'm going to put square root of y minus 2 the whole square plus x minus 1 the whole square. Now we know that the equation of a parabola in vertex form looks like this. So my final answer has to look like this. I need to have y on one side is equal to everything else on the other side of the equation. So in order to make that possible, we have to simplify what we have here. So since we have a radical on the right side, we are going to square on both sides in order to get rid of the radical. So squaring on both sides, I have to put whole square, the whole square like that. So we're going to apply the rules of factoring. I can quickly show that to you guys. How can I do y plus 4 the whole square? Okay, y plus 4, when I square it, I square the first term, that's my y square, and then the middle term is 2 times 4 times y is 8y, and the last term is when you square the 4, which is 16 square. So this is the identity that I use. You can pause the video and write down notes if you need to know that more of that, how this is done. Anyways, I'm going to expand it using the identity a plus b the whole square. So here this y plus 4 the whole square becomes y square plus 8y plus 16 is equal to, when I square this side, the radical and the square cancels, and I'm left with y minus 2 the whole square plus x minus 2 the whole square. So I'm going to leave the x minus 1 the whole square just like that. I'm not going to expand it. I'm only going to expand the y part of it. Okay, so y minus 2 the whole square, again I want to go to that screen and show you that. Y minus 2 the whole square is this one. Square the first term, multiply all 2 times negative 2 times y to the middle term, and the last term is a negative 2 square, which is positive 4. So let's write that there. So we get y square minus 4y plus 4. So when we look at this, we see that both the equations, on both sides of the equations, we have y square as a common term. Y square is here and y square is here. So cancel that. Now we know we need our equation in the form y equals a x minus h the whole square plus k. So in order to accomplish that, I am going to add 4y on both sides, 4y. So I'm going to get 12y. I don't need this negative 16 here. I need everything to go on the other side. So I'm going to do minus 16, minus 16. So I get negative 16 cancels, x minus 1 the whole square, they cancel, and I get negative 12. So I need only the y for it to look like the parabola of equation. So dividing by the constant 12 throughout, the coefficient 12 throughout, they cancel. I get y is equal to 1 over 12 x minus 1 the whole square minus 12 divided by 12 is 1. So this is my equation of the parabola. So when you compare it to the general equation, we can see that the vertex is hk, which is 1 comma negative 1, which is exactly what we had in the first place when we graphed. The vertex here was 1 comma negative 1. I wrote it over here actually. So that's how you find the equation of the parabola. Now one more thing you need to know is how do you find the y-intercept from this equation? Okay, the equation of the parabola that we got here is 1 over 12 x minus 1 the whole square minus 1. To find the y-intercept, you have to put x is equal to 0 and solve for y. For that, 1 over 12, instead of x you put 0, the whole square minus 1. So you get 0 minus 1 is negative 1. Negative 1 square is just 1. So you just get 1 over 12 minus 1. 1 can be written as 12 over 12. And you get your answer as negative 11 over 12. So the y-intercept will be 0 comma negative 11 over 12. That's it. So going back, you had the equation of the parabola, you have the vertex, you have the equation of the parabola, and also in the last screen you have the y-intercept.